Our next presentation is from Nemanja Kamenica, who's a technical marketing engineer with Cisco. And he's going to give us a nice talk about expanding your production remotely or to a public cloud. Take it away, Nemanja.
Hello, everybody. Welcome to the session. So I'm going to tell you, I've been here on Saturday, talk about how you can create your SMPTE 2110 fabric, but this is kind of like an extension of that same session and tell you how you can expand your production remotely, in a sense, if you have multiple locations which you need to combine, as well as some other use cases kind of going along the same line. So that's what I wanted to talk about today. So first, just brief touch on the deployment scenarios. So what I mentioned on Saturday, and then tell you about remote production. So either a small environment or something which is larger, or multiple environments at the same time. How you can do contributions, so something which is temporary as a stadium or something of that sort. Distribution to a public cloud or anywhere else. And then handoff as well to the public cloud, and then importing or decoding and decoding of content in the fabric itself. So when we talk about deployment scenarios or deployment options, there are two major ones. The first one would be spine and leaf deployment, where that could be like plain spine and leaf deployment with set of spines and set of leaves and endpoints connected only to the leaf layer. Or you can make it like more of a hybrid, where those endpoints, cameras or multiviewers or microphones, are connected to both leaves and spines. So that works. Benefit of this, it's distributed scalable approach. And you can expand as you grow. And then the other type of deployment, it's monolithic deployment, when you have a single switch. Could be a modular switch with a lot of ports. So you connect all of the endpoints there. Benefit of this one, it's simple because you don't have multiple devices, and it's very simple to configure this type of a fabric, as well as it's centralized, so you know where you need to go with your equipment. So when we talk about spine and leaf deployment, you can have it more kind of flexible, so you could have multiple studios connecting to set of switches, so you can dedicate set of switches per studio, as well as set of switches per production control room, as well as you can connect master control room to your spine switches. The other type of deployment, if you would have like a post-production environment into the fabric, you can dedicate a couple of switches to that environment. So all your fabric sits in or all your equipment, all your studios, as well as post-production sits in the same fabric. So transporting all of those signals, it's very easy in this kind of case. That's one way of doing this. It's the same fabric. It's very easy to kind of do this. But what happens if you have a remote site? So something which is local in a different building or somewhere not so distant away, and it's a smaller production, some limited amount of endpoints which you need to connect. So you can dedicate a leaf to that site. So imagine that you need to connect multiple, like this hole to another hole at IBC. You can do that by just expanding to another leaf to another hole and connect those endpoints there. But what happens if you have, so based on session which I did on Saturday, you also treat this leaf as any other leaf in the fabric. So you manage the bandwidth between that leaf and the spines and other leaves in this kind of case. So it's treated as seamless part of the same fabric, even though it's in a distant or a different location from that standpoint. But what happens if you have multiple fabrics? So I illustrated this. If you have a fabric in Amsterdam serving this area over here, and let's say that you have another fabric in Brussels serving that area there. So serving Netherlands from Amsterdam and serving Belgium from Brussels. And you need to import or export signals from one location into another location. You can create something which is called multi-site. So each of the location will have its own site, either that's a monolithic or spine and leaf site. And you kind of connect those two sites through a dedicated redundant dark fiber connection. So they're directly connected. You know how much of the bandwidth you have. You control that bandwidth over those links. So you treated these as kind of part of the same network. You also manage the bandwidth inside of each of the fabric, as well as you manage the bandwidth on those links between two of the sites. Just one thing which I want to mention here: when you create this kind of multi-site environment, it can have two sites or multiple different sites. You need to take care of the PTP. So either you have one grandmaster or a grandmaster serving both of the sites, or you isolate PTP between the sites. So what that means is that you are not transporting PTP over that links between the sites. So each of them are synchronized, and also both of the sites are synchronized to the same source. So you have both sites running in as a source as GPS in this kind of case. So they do indeed have the same time, and those signals which are traversing between the sites are synchronized in the same way. So pay attention to that. I mentioned this, you can have multiple sites. So in this case, I have Amsterdam and Brussels connected through dark fiber, but I occasionally might import some signals from London or Paris, or both. In my case, both. So I might have a public internet or WAN connection connecting between these two sites. So I can do that, treat those as different sites in the environment. And I also need to have both unicast and multicast reachability between all of the sites. So that's one thing, like what you're capable to do in this case. So let's talk about another problem which may occur. And I would say this is somewhat of a common problem. So let's say that you have a soccer game, or football game. Ajax is playing on their stadium. And you want to import those signals to Amsterdam studio or Amsterdam network, which you have. What could be a problem here is that groups which you're having, multicast group which you're having, are overlapping between two of the locations. So they use the same multicast range. So what will happen is that you cannot import those groups as easy. So what do you need to do is that you need to do a network address translation, NAT. So you change the range which is coming from the stadium. So how you do that is you do that through a multicast NAT. So on our left side, coming from the stadium, it's group 239.1.110, which overlaps with your range which you use in your network. So you translate that address into 237.1.10.10, which doesn't overlap, doesn't exist in your system. So you are able to use that multicast address. So how that helps you is that at a point in time on that ingress switch, the first switch on the left, on the left in the fabric, you translate that signals from that S4G1, that 239.1.0, no, what was the group? 239.1.110. You translate that into 237.0.10.10 group, which you can use, and you do that for all other groups which are coming from that system. So you don't have overlapping range, and you can route and use those groups or those signals the way you wanted it to use. So you solve that problem using multicast NAT. How multicast NAT can help you as well. So let's say that you have distribution to different consumers, TV stations. So you need to distribute same signal or signals from your network, but you want to hide your internal subnets, your internal information from the network. So you don't want to distribute them and show to everybody what's happening. So what you will do, you will have a demarcation device. That demarcation device will mask your internal subnets or your internal addresses and distribute them in a different, with different IP addresses as source and destination, which you can negotiate previously. So how you do that, you do it as well with Multicast NAT by changing the source and destination or just destination addresses, probably source and destination. So in this case, we are translating S3G3 into S3G30. So it's totally hidden, totally masked to everybody in the distribution network, what you're doing internally in your network. So another use case for the Multicast NAT when it comes to distribution. Okay, how do you forward information to the public cloud? So what's the problem with the public cloud? Usually you would need to transport it over public internet, and public internet doesn't allow you to transport signal with multicast address. Simply they don't support, they will ban multicast from their network. So the only way for you to do it is through unicast destination, unicast routing. The other thing is some of the public clouds, maybe majority of them, do not support multicast in their network. So for you to import those, you need to convert it into unicast. So how do you do that? Using multicast to unicast NAT. So on the left side, we have 239.1.110 address. When you translate destination IP address into unicast. So this flow becomes 192.168.110. It's a private IP address. Possibly this would be a public IP address to translate, but just an explanation. You are translating that multicast traffic into unicast. So it's multicast to unicast translation. So this will allow us to forward that multicast traffic originating locally into public cloud for any further processing or whatever you can do. So you can route it over public internet, or you can even import it to the cloud to an instance which needs to do something with it. And then another case is decoding video signal. So let's say that we have some kind of source which is sending unicast stream, and it's sending it over public internet. So everything works, everything is fine, but you need to receive it on two decoders in your studio environment or your environment locally. So you can ask your source to send you two streams, unicast streams, each destinated to a decoder. But there is another way to do this, which is a little bit more efficient way. So you do that, distribute traffic through devices using multicast address as a destination. So what you will do there, that unicast destination you will translate into multicast, so more efficiently you can forward it and distribute it through your fabric internally to those two decoders which you have. So how do you do that? So we have here destination on the left, which is 192.168.110. You translate that into multicast, like similarly as the previous, just in reverse. So you transport it into, or translate it into 239.1.110. So what happens here, once when that signal reaches the, again, first switch on the left, you translated it from that multicast address into unicast address and forward it to those decoders as multicast. So you transport single stream from the source to the spine, and then spine will replicate it and send it to each of the leaves where decoders are present. So as a conclusion, so what is the benefit of the IP? It's flexibility. So all these operations which you need to do to transport the signal, you can do it through an IP infrastructure, through switches. So you can satisfy a wide range of the use cases from perspective of the multiple sites which you interconnect or translating signals. So you can distribute them in a more efficient way. Interconnecting multiple geographically distant location through multi-site deployment, importing signal from a stadium or exporting it to the public cloud. You can do that as well. And transporting signal, converting them from unicast to multicast, that's also capable to do, or you are capable to do with IP infrastructure. And everything which I mentioned, all of the use cases are supported with Cisco Nexus 9000 switch family and IPFM deployment. So be aware of that. So any questions before I finish? Was this clear, useful? Yep. Okay. Well, thank you very much.